morning, everyone. I am so pleased to have you join us at the Polish Business Hub. I'm sure you're only half conscious after last night, so we appreciate it even more. We're gonna wake you up with some incredible programming on space flight, aviation and space technology, drones, satellites, and industrial applications. I'm Christine Lee, advisor to a Web3 firm called Quantena.org. I'm also a journalist in the technology and finance field, previously with Bloomberg, Reuters, and CoinDesk. All right, let's go down the panel and have introductions for us this morning. We're gonna bring the energy because it's a long week. All right, let's start with Jussi.
Okay, good morning to everyone. So I'm representing here a company called Summa Defense, so founder and the director of new technologies of the company. We have a wide range of services from very traditional shipbuilding industry up to the drones where we operate with the Ukrainians. And I guess this is the topic we are discussing today. So company is listed in Nasdaq Helsinki, Nasdaq Stockholm, and basically building the umbrella group of the companies where we are providing then scale-up possibilities and R&D support, sales support, etc. So strong growth appetite.
Incredible. Yeah, we're going to definitely deep dive into all that's happening in Ukraine and what they're doing with drones. All right, Brontë.
I guess that's a good segue to myself, Brontë Hamilton. I'm with Destinus. We do drones, or also referred to as UAS, unmanned autonomous systems, across a range of capabilities. We're a multi-country European company with also presence in Ukraine and supporting efforts there. And I'm the CFO for the company, and we're 3 years into rapid growth. So scalability, resilience, and how we interact with the ecosystem around us, and you'll hear from a couple of the other members on this, is really critical. Really happy to be here today, and we'll go slow to warm everyone up on this morning.
Great. Lisa.
Good morning. I'm Lisa Rich. I'm founder at Xplore, which is a commercial space services company delivering imagery from space with satellites that are multi-sensor, and in the future we'll do on-orbit processing and edge compute. Also the founder of Hemispher Ventures, which is run by a partner that has investments in over 30 commercial space companies, including ones that are going to go public this year, like Axiom Space and other, which is doing commercial space stations. So I'm a space gal. Great to meet you all.
Excellent. And Johannes.
Hello, dzień dobry, as we say in Poland. I used to be the CEO of Airbus Poland, and 2 years ago I set up a startup company called Draco Aircraft, with which we will help to revolutionize aviation with an aircraft that can take off and land in less than 100 feet, just the length of a basketball court, and will come with an autopilot system assisted by AI that will allow you to fly safely at all times, and finally fly this aircraft fully autonomously.
Fantastic. Okay, we'll get a sense of aviation in Poland with the startups that are on the ground. All right, so I just want to get a sense of our audience here. How many of us are in the space industry or have any familiarity with it? Or okay. Oh, okay. Or how many are just complete beginners and just want to learn about? Okay, so half and half, okay. Well, I mean, this is going to be an incredible year for space, for aviation drone satellites. There are about 10,000 satellites in orbit right now. The industry is about $500 billion and growing. And there's going to be an historic mission, the Artemis project in the US, that will bring men, well, or women, men and women, to the moon, around the moon for the first time in 50 years. And so I think this is going to be a very talked about year about drones and whatnot. So maybe we can go into what innovations we're seeing in your industry that might surprise the audience? And obviously, Jussi, we want to know what is happening in Ukraine with your drone project and how you're navigating such impossible terrain in a war zone.
Well, yes, if you talk about production in Ukraine, obviously there are challenges. You need to hide the production places. You have to be flexible to change the places. So it's really difficult to have like proper production lines which stays in the same place long time, and that's actually the reason why we work with some Ukrainian companies, and we are scaling the production in Finland as well. But then this causes another problems because of the logistics. Of course, it's lower when you have a production closer to the combat zone. You can react faster. And then there are like a material logistical challenges also, as we are using some of the parts which comes from Ukraine. So first you have to send it out from Ukraine to Finland and then back. That's not so smoothly as you could think or imagine. So there's a lot of this kind of like very basic challenges how you scale up the production. The knowledge and understanding, of course, Ukrainians have the best understanding, as at least from our point of view, what's working and what's not working. The circle of the development is very fast, and I guess we are touching the point a little bit later, like how this R&D and these topics can be more flexible, and how the, let's say, the traditional bureaucrats or purchase department, they can't really hold on this speed. So many things to tackle. Also, maybe a little bit about the certifications and certificates what you need in Europe or other areas, and then of course when you are in the war, that's not the priority one, which causes also challenges when you produce outside of the war zone. So
Okay.
quite challenging.
I used to just to get a sense, but where are you based? Where are you from?
I'm from Finland.
Okay.
And our production is in Finland, but of course our partners are having production in Ukraine, in many places.
Can you share what the drones are actually doing in Ukraine, or what they're being used for?
Yeah, so
who's operating them?
our concept is that we are not developing as a Summa Defense our own drones. So we are trusting the products what Ukrainians are using, and it's like a proven technology on the combat zone. So basically, currently we are providing or producing like a copter type of drones, different sizes, different like operational lengths, but we have capabilities to produce like from the very small copter up to the fixed wing long range, like plus 1,000 kilometer drones as well. So but currently it's more like a short distance, like a very short, which is used by the special forces, then fiber optics, which is of course interesting solution these days to be able to operate, and then a little bit bigger one with the some tens of kilometers of the range. So.
Is it mainly surveillance, or is it?
No,
They can drop things?
these are mainly kamikaze drones. These what we are now producing. So, but what we produce outside of Ukraine, so actually the explosives are loaded then in
That
Ukrainian
is
side.
Frightening.
Yeah.
Okay. Well, at Destinus, you were also focused on drones, so maybe you could talk about the edge you're bringing about in Destinus, and maybe something that would surprise our audience about the innovation coming up in the future.
No, thank you, and thanks for facilitating us today. And thank you to the audience for spending time. So, great segue, and I think you touched on something. The cycle of innovation is incredibly short now, 2 to 4 weeks. So the companies that will survive in this space are the ones who can, there's a concept I referred to earlier, OODA loop, and it's a very old concept in the military: observe, orient, decide, act. And even if you don't do that perfectly, if you can do that fast, you will learn faster than your competitors or your enemies maybe. So what we see now is in a battle space, you have to be operated at that tempo. If you go back to previous wars or conflicts, that tempo might have been years. And you saw, for example, in the Irish conflict, that might have been years or months, and then it's come down in time. So I think that aspect is critical. As we think about space and we think about the technologies, obviously the technologies we're using, similar to some of the partners here, we're looking at a combination of aviation hardware, but with AI ML development of autonomous support systems that help drive certain aspects and capabilities. What I think is fascinating with space, and I've read science fiction since I was like about this high, because it talks about how humans adapt to unforeseen and significant changes. I think what we might see with space is it won't be anything remarkable, and then suddenly it will be everything. Because what is visible to us is, I'll call it the surface technology. When you see a shuttle or you see a satellite, what you don't see is the absolute exponential development in the enabling technologies that sit behind it. Data, security of transmission, computing power. We have obviously the rise of quantum computing, materials technology. As that proceeds, and maybe this is for later in the discussion, I think there's an interesting parallel discussion around how do we govern this? Because we have a strange mix of private and government governance that works within the world. How does that work in a space environment? So yeah, fascinating times.
Wow, yeah, there's a lot to unpack with that one. But I also want to get to Lisa. You are also on the satellite spectral side of things, and you also have something to share with the audience. So I'm excited to see a bit about that.
Sure, but I'm going to take off from what Brontë was talking about is innovation, and really that what's bubbling up, these foundational layers of capability that are being built that we don't see, we don't hear about, but it's happening right under our feet. And as I like to say, at the point when these are completed, then we turn on the spigot. We haven't turned that on yet at my company. We're working on a collection of hyperspectral imagery from our satellite and have thus far proven against competitors that we have the best quality hyperspectral imagery in the world, 5-meter imagery that we can resolve to lower resolution. That's phenomenal. And so I thought I'd show some pictures of hyperspectral today that no humans, other than those at my company, have seen before, not only because they're beautiful, but to just kind of set the stage for what this type of imagery is and why it's important, is that it's sort of like unleashing the internet as opposed to the optical imagery we have today. Camera has red, green, and blue wavelengths. That's 3 bands of color. A hyperspectral image has 100 and orders of magnitude more bands of colors, but every single band is tied to a spectral identifier of the chemical properties of the band. So you're basically understanding the material properties of what you're looking at on the Earth or in the oceans or other satellites from space. So you know if this is a drone, or if it's a metal tank, I should say, or if this is a decoy canvas. You know if this is on the ocean, if there's an algae bloom, for example, or indicators of ocean activity because of the trails of boat wakes. So it's getting really interesting in terms of the types of things you can see. So I did bring a few images because this color is so outstanding. I think even the back of the room, you'll be able to say, what am I looking at? That's so beautiful. Oh, sure. If you can. Sure.
And this is some of the best imagery in the world.
This is some of the best imagery in the world. We're looking at Sao Paulo, Brazil, and even the water, all the different degrees and different colors in the water are telling us about boat wakes and activity on the water. There could be oil slicks that we're seeing. We don't do the analysis, but our company is the the collector of the high quality data. So our forte is the integration of the instrument on the satellite, and you can switch to another one, and then the ability to capture this large quantity of data from the satellite, bring it down to the ground. In that case today, we're bringing it to the ground. And then we're compression and decompression capabilities to produce the highest quality outcome. So denoising of the files, this is where that innovation of, look at what we were able to do this week in terms of the higher quality denoising on a file. It's happening so fast. So that last one was Iran, by the way. This one are farms in Europe. We can see down to the crop row. We can know exactly what plants are being planted from space. We've actually done a test. I know we flipped from Iran, but we did a test of showing on a flat satellite how we can observe, as an example, poppy fields, and with an onboard processor, identify poppies and just download where are those located, instead of downloading the huge files and having analysts study them for a certain amount of time. We would know instantly where are the poppy fields. This one is just beautiful. I think you could see that at the back of the room, this beautiful color. We're looking at Australia.
I was going to say Australia, right?
It's Australia, right. And so all these different colors, a lot of them, I'd like to point out, cannot even be seen by the naked eye, because this isn't about creating beautiful images for art. Thank you. It's really
Can we
about
pass them around?
AI and ML machine learning, because you feed this file of the image into a computer and you tell it what to look for, and it can find all the bands, and it can assess and analyze what it's looking at. So this is very exciting. Thank you, Christine. And I thought you'd all enjoy that today. It's my special treat to share. We have
Great wake up.
Thank
Yes.
you, thank you. And we have thousands of these images, so these are just a few that we did as samples. So anyway, thank you for letting me share
Yeah,
that.
no, absolutely. Beautiful imagery there. Johannes, you're also a startup in the Polish aviation industry. Tell us a bit about what you're developing and how this will change the consumer experience in the future in your effort to improve mobility in the future.
So if you allow me to add on what Lisa said first, because before setting up Draco Aircraft, I was responsible for Airbus space business. And nicely adds on what you just said. So the Airbus hardware space business today is a 3 billion business. In addition, over the last 15 years, Airbus built up a service company or service companies that deal with space-derived data management. So, and this business grew from 0, meanwhile, to over 1 billion. So, and it just shows you the dynamic of what you explained, Lisa, of what you can do today with information of all different sorts derived from space. And it underpins, and that leads me to your question, it underpins the fastness in which technology today develops. And this is true for space, it's true for aviation. So allow me to add with one space example. Today we produce satellites that are very costly, mainly for one reason, because they need to survive the first 10 minutes of their lifetime, meaning the huge stress that a satellite is being put under during the launch phase. If you now imagine that we could produce satellites in space, then you can forget about a good part of what we now need to invest into making these satellites survive the first 10 minutes. So there are already printers that can print in zero gravity, what is a huge technological challenge. So it is solved. Nobody sees it. Yeah? On the International Space Station, there are 2 printers, meanwhile, one for minerals, one for plastic. So now imagine that on the moon, you do not need to take anything with you what you need to do when planning a manned mission. Yeah, and if you forgot something, no way to get back and get it. Yeah, so just imagine that in the next decade we will have robotic printers on the moon that use the material that you find there to build habitats, to build the tools, maybe even the shovel that the astronauts will need to work. So that is one thing. Same thing happens in aviation. So we are all used today to the way we fly today. Yeah, if we think of commercial flying, it is a hassle because you need to go to crowded airports. You cannot fly to where you want to go to, but to what the ground infrastructure allows you to do. So the next big thing in aviation is allow everybody to fly door to door. Yeah,
How do you manage the traffic of that?
including to get to Davos in a more convenient way than today. So what you need to that is autonomous flying. That links drone technology to aviation, because of course you cannot have millions of aircraft just flying around without being controlled. So, but if you think of what we have already today, at least in the United States and beginning also in other parts of the world, we do have autonomous ground transportation, yeah, with companies like Waymo, a taxi without a driver. So what we will do is we will take this technology and bring it to the next dimension, allowing autonomous flying in the air. So that requires AI. It requires cyber technology, because you need to protect the aircraft against unwanted interference of any kind. And finally, it leads to something, that's my last word, where you will see that drone technology and classical aviation technology will merge. Because if you have an autonomous aircraft that can fly without a pilot, it is a drone. Yeah? And vice versa. So the technology development in drone industry with the speed that you described, Brontë, and the development of technology in aviation, they go nicely together and will change aviation forever.
And you're developing.
And we are doing this.
Where can people see this? And when is it already launched?
So if you go on our webpage, dracoaircraft.com, you see our prototype flying. They can take off and land in less than 100 feet. Wow. So it is like a helicopter, but we can go 3 times as far. It costs only half of a helicopter. It's highly attractive for private pilots, but it's of course highly attractive to our defense needs as well.
And I would just add to that, this is public. Destinus just recently acquired a company called Dedalian, Swiss-based out of Zurich, and they have been working for 9 years now on autonomous tools. There's something called visual flight, and about 80% of flights are done through visual flight by the pilot. This was a tool in the civilian space to help with that and identify targets in the air to avoid. It's actually in some ways an easier problem to solve than the ground. Because on the ground, there's lots of humans doing human things, which aren't always rational when you drive, or if you're in Davos, you've seen this. So what we've done is take that technology and innovation and bring it across to drones. And absolutely, to your point, I think what we're doing now fundamentally changes the landscape of not just conflict, but also the civilian and commercial world. And you'll get this, hopefully, unitization of transport, where it becomes more and more concierge or custom, leveraging these technologies. But it is not easy, right? These are very, very smart people doing very deep. People now go to ChatGPT as AI, but this is deep models and learning and neural networks. So.
Well, it just blows my mind. I mean, because now we have the Waymos who are doing the autonomous driving. We're seeing that expand in cities across America. So if this expands to aviation, you're going to have to map out the airways and have that developed by AI. And this kind of leads to my next question, which you had brought up. We're going to have that moment where space aviation is nowhere and then it's everywhere. We saw that with artificial intelligence, where 10 years ago, not much thought of it, but when ChatGPT released their their new models, and we're seeing these large language models coming out. I mean, now we use them every day. I wonder, when are we going to see that happen, that moment? How far are we out, and what will be the killer app for that?
I can maybe do a quick start on that, then hand to the other. So one of the things that Dedalien, now Destinus, is doing is, how do you certify an autonomous aviation tool, right? Aviation is not known for its risk appetite, right? Rightly so, and you know this probably far more deeply than I. We are having to work with organizations like the FAA to help them understand, how do you build the testing systems to test the thing that we are doing that will go into this space. So as with many other areas of technology, not just the regulation, but the ability to determine what is good is lagging significantly behind the developments. And this is something that we will need to resolve rapidly, I think, but is not as obvious perhaps as the technology itself.
Yeah, I can just add to this, the testing systems are so key, and this is almost like they say, the problem of last mile delivery. To finish out your capability, you need to have verification that whatever your data is 100% verified. In space, we use the terms ortho and georectification of a data file, and that is really important for the end customer, especially as they need to know whatever that they're looking at is exactly calibrated to that point on the ground, that those locations are indeed correct. I don't know why I'm thinking about this, but just the stories recently about the border markings and Gaza being moved, the mile markers being moved, and seeing on the satellites that indeed they physically moved mile markers, things like that. This verification is so important, and as well as we're using layers of AI and ML technology, you don't want to have corrupted data. So in our case, with the data we collect or from your drones, et cetera, that's original, pure, uncorrupt scientific data in its original form. So same with Xplore, as these satellites are uncorrupted data. So, but what happens as it goes down the food chain and it gets merged and melded and mixed every which way to get to the end result of the algorithm that's getting an insight. This is where we're going to have, I think, more challenges, I would say.
Yeah, and if I just may add on, what we all need to keep in mind, that there's of course a big difference with regard to data security between our civil world and when it comes to defense, where you have every good reason to believe that there will always be other people around that want to interfere with your data. So that is the one topic, and the difference between fully autonomous drone flying and if you have people on board. None of us would put her or his life at danger if you can, as long as you cannot fully trust that the data that is used is accurate. So to give you a real example, in the United States alone, we have more than 1,000 accidents with small aircraft each year. And obviously, today we accept this fact that lives are actually unnecessarily lost, mainly due to pilot error. Yeah? So if for whatever reason now you want to land such an aircraft without the pilot's help, maybe because she or he is incapacitated, yeah? So you need data that is absolutely accurate and reliable in order to land this aircraft autonomously. So and that is what we are working on in Warsaw, together with partners worldwide. You need sensing systems, you need geolocation data, yeah, because you do not want the aircraft then to crash into a tree that has not been documented in your data. So So that gives you maybe an idea of the challenge that is ahead. It is still a challenge, but I think everybody who is working on this today understands what needs to be done. So it is a question of time, and I would say a question, to come back to your question, Charles, of a few years, 5 years, and it will be done, I think, today.
Let's bring you into this conversation because you're also marrying a lot of technologies at Summa Defense with AI and edge computing to actually track down targets and autonomously strike different targets. So maybe you could talk a bit about that and how it's able to do it completely dark.
Well, adding to this conversation, what was already here, so I think the technology is already there. It's everything ready, but when we go to the defense side, the question is then how you recognize what's your own troops and what's then the enemy troops, and who makes the selections in the end of the day to hit to the target. Of course, there are needs for this like autonomous capabilities to do the hitting to the targets, not just because of the jamming and these things. Okay, there are fiber optic solutions for that as well. But if we take example Finnish military, which is mainly the reserve military, where you can mobilize 1 million people to the army in the crisis situation. Most of those people are not ever touched the drone, but in the modern warfare, you need to be able at least somehow operate the drone. So then comes the question what we are working, I would say it's kind of like a last mile application that you can, everyone can take the drone up and fly it close to the target, but when you need to hit it, then you need to have some capabilities. Of course, the skilled operators can do the miracles, but most of people don't. So then I think there will be this kind of like period of time when it's already in use actually, so that you can, the operator is locking the target, but then the drone goes autonomously to the target and hitting it. So this is reality, and it's developing very fast. Then what comes to this R&D topic, what was touched here, so if we look again the defense side, so before the full scale of invasion by Russians to Ukraine, most of the countries have been developing the procurement processes for years to be perfect, and that's very slow. And then, of course, in Ukraine we see what happens when you have to be able to develop and be fast, but there is a big challenges on, let's say, countries which are at least at the moment in the peace to speed up. We need kind of like a startup type of mindset here where the private companies are working together with the officials and militaries. Of course, I understand that not every company cannot be testing their products. It's like a mess then, and you have thousands of startups which everyone wants to be the one who is working with the military. But these are the challenges where we have to find the solutions to be able to develop faster. But technological point of view, I think we have already the solutions for the autonomous. And what comes then to the aviation, so if we compare US and Europe, so I think the Europe, the challenge is we have so many countries here, everyone have their own air traffic control, which is actually, if you compare the air traffic in US and Europe, US, you get much more traffic to the airports than in Europe because it's centralized system. So this is something what needs to do in Europe as well.
And that's a topic that you touched upon, which is space governance, let alone Earth governance. So how do you see that evolving? How do we find a global way to cooperate and regulate these airways and then space and beyond?
I mean, this is a really hot topic right now, and at different levels of scale. And this is critical for the EU at the moment because there's NATO interoperability, and I'm very passionate about this. Most of the complex problems we need to solve are ecosystem problems. They're not linear problems. They're ecosystem problems. And a characteristic of that is as you solve one area, another bottleneck or shortcoming arises elsewhere. Another characteristic of this is now you're seeing there are a number of regulatory and governing bodies that have evolved for very good reasons. Police manage the ground. Airports and air traffic control manage the space around an airport. Militaries manage certain areas of operations. Now, if I have a drone, it can be as simple as, how do I test a drone that can go up to speeds that will get close to Mach 1? You need a little bit of room to test those things, right? People get a little annoyed if you fly that over their house. So you've got everything from how do you do testing and who do you need to get permission from? And I know everyone has probably got stories on this. You get permissions from 38 different agencies, and then you go to do something, and an agency you didn't even know exists pops up and says, no, you can't do that. We need innovation in this space, right? We need to innovate how we govern so that we manage the risks appropriately, but don't constrain our ability to deploy certain things. And for EU, this is going to be really interesting because you have fractured budgets and fractured countries that if you want to build a overwhelmingly strong and resilient capability, we need to find ways to interoperate private sphere, government sphere, military sphere. Yeah. So it's not going to be easy. Sorry.
So do you see that developing into a global cooperative, or is it just too adversarial for something like that to happen? Who wants to take that one?
It's what's interesting to me is I met just here at Davos an interesting group that's working on being that neutral source we kind of touched on space traffic management a little bit. And the challenge today is that there are companies tracking where satellites are. You want to have collision avoidance, that type of thing. You need to know with navigation where you're going to target your next imagery that you collect, your next collections. But this group that I met was looking at having agreements of adversarial countries agreeing to have a platform where they're supplying information of where their satellites are so that we have a collision avoidance, but they're not directly going to be in touch with the people that are flying their satellites. So it's almost like you have companies with space traffic management telling you where your satellite is today. We use in the US, but they're missing that data from where are these other people's satellites, where are they flying? And so if you have this neutral party, and it was sort of a subscription service or something, I found that fascinating because I would subscribe to that, to just have knowledge of where they are because they don't want to hit us and we don't want to hit them. And by the way, this is not, space is really big. Collision avoidance is not really a problem today, but it may be in the future. I mean, there may be situations if it was on purpose or something like that. We don't want that to happen, but it might be part of our future story.
So many people might not know that one of the tasks of the United Nations is to do just what you just said. If you want to launch a satellite, you need to ask for permission. Where do you want to put your satellite? So there are already certain constraints. The question is whether everybody, take a country like North Korea, really sticks to these rules. Satellite avoidance is a huge issue, and there have already been accidents in space, satellites colliding, and that has to do with a problem that you mentioned before, and that is how precise can you locate a satellite. And there have been mistakes because a satellite moves in a cloud of uncertainty. So let's say 100 meters left and right, you do not know where it is. So and if two satellites approach each other, in the ground station you need to make decisions on, do we want to move our satellite in order to avoid a possible accident where you cannot really calculate the likelihood it to happen? And why why are you so careful with it? Because you burn fuel. And the one thing that you can't do in a satellite is to refuel it. So you want not to use your fuel just to fly an unnecessary maneuver. So you need to take a certain risk and hope that the satellites don't hit each other. So that is the one thing, and we will become better and better in this, but the topic is that the number of satellites grows quicker than our ability to improve our geolocation. So that is the one thing. And on ground, as always in life, meaning there were no traffic controls on ground 150 years ago. Everybody did what you wanted to do with your horse, and if you ran someone over, too bad for him. Yeah? If you remember the guy who invented modern X-ray technology, Mr. Curie, he was run over by a carriage and died. And in aviation we do have the same thing, meaning with increased traffic we will have improved regulation. And the point is, yes, will that happen quickly enough? And Europe is a good example, be it in Poland or elsewhere. It is, from a company perspective, it's ridiculous that we have dozens of different safety agencies looking after the same problem. We need one unified, at least European system to do that. Yeah? So there's so much to be improved, and it needs to improve now. And that is a message to politics, that they need to speed up in order to follow the speed of the technological development and the speed of growing needs if we come to defense, for example.
Without inhibiting the process.
You see, when we think about collaboration, scalability, do you think that'll come from a drive within the private sector or the public sector, or a marriage between the two? Well, I think you'd all be biased toward the private sector. But
I think our business concept is that exactly that the private sector is taking, of course, the risks and investments, but it's true that when we're talking about the defense, there are big clients, nations, armies, militaries, which have to be also able to adapt their processes to be then faster, and then this testing startup mindset is something what we would need here on that sense.
okay. Actually, here's another question for you. We know that some of the best technologies, like the internet, come out of defense, and then eventually they come to become more friendlier technologies that retail consumers could use. What do you see that application being in the future?
Well, dual use is generally, of course, always when there is a crisis in the world, certain technologies are developing much faster, and then later on it's adapted to the civil world as well. I see that here was a good point touching this, that we have a lot of satellites and lot of actors and different companies operating. I think this is there will be some kind of system integrator or space mesh type of thing, which is then combining the information from the different sources. It's like connecting all the way from the drones up to the satellites, the information, and because now we have fragmented information from many different sources, and you can have a lot of data, but it's no point to have a data if you don't know how to use it. So you need some kind of like integrator. I think that's gonna happen sooner or later.
I actually struggle with the term dual use, and I think particularly in this environment, anything can be dual use. I think lasers came out of some very pure research, and then you can apply those lasers for beneficial reasons or for less beneficial reasons. I think what happens is, in a conflict situation, the actors are incentivized to innovate rapidly, and you get a Darwinian system where response and counter-response happens very quickly. And I think this accelerates the development of certain things. I'm fully aligned that I think, and the good points raised about you also need to innovate in the procurement cycles of our end customers. They are learning how to buy from us. That's another type of innovation. And a little on the governments in the space, as that becomes more crowded, what fascinates me is, will there be a point where political power shifts to space? At the moment, it's just knowing where satellites are. Over time, they become the body to resolve disputes between satellite paths? Add potentially external resources like asteroid mining or different capture of helium or other types of resources in space into that mix, and you now incentivize the players differently. So I think there's some, with the project to get people onto the moon, whose authority do they reside under? How long do you listen to your governing nation when you're a light speed lag away? I think these are some really interesting questions.
Wow. I also want to, we've got about 10 minutes left. I want to open it up to the audience. If anyone has any questions out there, just raise your hand and I'll come around to get to you. No questions there yet. All right. Well, in terms of that governance, we talked about a bit collaboration. Do you see that data going open source so that it can be shared among satellite information to the drones through the autonomous aviation? Is that a possibility, or will it be more of a closed system?
So open source data is what's available now that's from Landsat satellites, and it's free, and people, companies, and groups that use it love that that's free. But what's free isn't necessarily what's useful. So when we're, as was mentioned, we're fronting all the risk to develop these technologies to get this unique data. Open sourcing it, I think forms of it will make sense. Since we can slice and dice a data file to produce different types of images and different qualities, you can take the same file and produce a lower resolution outcome or the highest resolution outcome. So this allows us to consider if that there was some need for open source to be part of some consortium for the benefit of this whole story we're talking about here. I think that can happen. But what excites me more is just that because we are commercial companies, with the ability to take data and up-classify it when we marry it with other companies' data streams, or to enhance it for enhanced commercial. So you end up with like an original product that can be married with other quality data streams to be better product for commercial, better product for classified. So that's really fun. And I think that as we take this data to provide it as metadata to feed the AI ML world, which, by the way, if you're investing in AI, the dirty secret is many of these companies are falling apart because they are starved for uncorrupted scientific data. They cannot access those data sets other than maybe from companies like ours. So, as we go into that ML AI world, there's more to do here on what open source might look like, I think.
When do you think we will be an interplanetary species? Now that you're getting into the space talk.
I think it's sooner than we think. And again, it's going to depend on the convergence of the enabling technologies underneath, combined with the incentivization for us to do that. And depending how the events, depending on how the events of the next couple of years go in terms of geopolitical conflict and stresses, I'd be interested to hear Johanna's version of this too. But I think it's within 15, 20 years.
Well, just to provoke a bit, Mars has always been 20 years ahead, so and there's a moving target, quite obviously. But I would agree, though we will get there, yeah. And whether it's in 15 years or 20 years, that we can leave that to history. Before we do that, as we said, there are huge challenges to be solved. It is one thing to put boots on the ground, be it on Moon or Mars, and go back. It's another thing to really go there and stay. And that requires technologies that we know we need, but that we do not yet fully have. So tens of thousands of people are working on it, so therefore one day we will get it done. The real question is, why do we do that? Is it just because we can do it? And I think that is a very positive motivation that humans have. Try things because you can do them. And the second one is what do we want to earn with it? And it's not just about money, it is about power, it is about knowledge, and so on. So in this combination, finally, will do this. But if we want to earn money as an interplanetary species, then we need robotics, we need all the technologies that we mentioned before, and that will be a very different world to live in. One that I'm looking forward to because it's super interesting.
Have you had some thoughts on this, Jussi, on going to space and beyond?
That would be interesting.
Okay.
Well, we are searching certain satellite applications to be part of our group as well. So I see this as a whole. Even we are now working only with the drones, but
So
as
do
I
you have some thoughts on whether it will be open source, closed source, collaboration?
well, certain level open source, but of course when we are talking military information, it's not going to be open. But could be shared. Example inside of NATO, such a group of countries. So yeah.
Sustainability. Okay, you mentioned that there have already been some accidents with satellites. So how do we manage that and all the space debris being collected and growing out there?
So the area that is at fault for these why did they collide is called PNT, which is position, navigation, and timing. And part of the reason it's complex is that you don't just use your GPS like you use it on a phone in space. So timing is a huge issue. Debris has been mapped. There are companies that have mapped all of the debris in space, so they know exactly where it is. That's part of the collision avoidance, is that they know that if there's a large piece of debris, you're going to have to want to move out of the way. I think I'm seeing more, I want to say, fractionalization of the goals of new emerging space companies, which I'm loving to see, that instead of a company emerging saying, we're going to find all the debris and collect it, which is just that's not feasible. They're saying, I'm going to take this piece of the problem and that will be my company. And that's what we need to see more of, because in the beginning of emerging space, at least in US companies, I think there were some really big and bold ideas that were not achievable, not realistic, that you could do this end to end. I'm going to, people say, I'm going to go to space with a satellite, collect the data, analyze the data, and get it all to the customer. Oh, and I'm going to build the rocket too. You can't do all of that. So every company identifying their specialty and place in this ecosystem, I think, is how we're all going to be sustainable and successful. As I mentioned in our case with Xplore, our secret sauce is the integration and understanding of collaboration and working to calibrate materials. So that's one of the specialties. And then working with the data on the big data sets to clean it up and deliver it. So I'd love to see more businesses emerging to tackle big problems like this, but pieces of the problem. because I don't think one company, there are companies like Astroscale that's looking to do space debris management. They are a very large company out of owned by Japan, and they will be doing missions for this purpose, but it's not just going to require one company or one, entity, I don't think.
Right. You see, here's another question. These technologies, is there a point where they're getting quite dangerous? So is there a invisible limit that we agree on collectively as humanity where we say, okay, we should not do this? and if so, where do you see that thought process headed, knowing that this could lead to great destruction or more very good in the future?
Well, that's a good question where you are putting the limit, of course. The possibilities there are existing already that you can go over the limits, let's put it this way. So
Or we just have to be very careful with how we conduct our politics in the future.
well, yes, but when you are in the conflict situation, the question is the other side thinking the same way, or if they are going over the limit, so you have to answer to that threat. So that's the problem in the modern world.
Well, just to add, your question aims at the question of whether mankind will be able to develop our ethical and political standards quickly enough with our abilities to do things, including do things that we should not do. And here, and it's both, it's ethics and politics. Well, depends on how optimistic each of us is to conclude how that will end. But if you, so one word on Poland, because we are here. Yeah. So I think it's a very good sign that a country like Poland, including the Polish government, decided just a few months ago that Poland would triple its investment into space technology, and in the future financing of the European Space Agency, all these over 20 member states, the one country that increased its investment most is Poland, just 2 months ago.
Who do you think is right now the top countries at the top of the game right now in the technology?
Well,
and where you see that headed? Like,
you mean globally?
Yes, yeah.
Yeah, globally, by far, of course, the United States.
Mm-hmm. But are other countries closely behind or just far off behind?
China is picking up. Europe could pick up, because you just need to remember that the European GDP is as big as the GDP of the United States. Meaning, if Europe would decide what Europe wants and then did it, then Europe could do whatever the United States can do. We just need to put our money where our mouth is. Mm-hmm. And that is, in life, a difficult thing to do. I think Europe is making progress if we talk about space. When it comes to Earth observation, Europe is the number one in the world. Peaceful Earth observation, be it climate protection or space-derived data, there's Europeans together do better than the United States do. And I'm not even mentioning the fact that the United States are currently even decreasing their investment into the peaceful use of space. But there are, Europe has to pick up in other parts of space-related technology, be it bringing humans to space and keeping them there, and to get them organized in a better way than they are today. The European Space Agency is a good example of what medium-sized countries can do together. And allow me to conclude, there are countries like India with a very ambitious space program. China has a super ambitious space program. The Middle East countries, the United Arab Emirates and others, have started to invest heavily, and it's impressive to see what they do. So meaning this is, in the literal sense of the word, it is a race that's going on in space and in aviation, and everybody of us just needs to be aware of it and be quick enough to win it. And I think, allow me to say, here are examples of what can be done.
We're actually over and out of time, but okay. But I'll just give you guys like a final thought that you want to leave with the audience here, a call to action, or something surprising and uplifting that they have to look forward to in the future. So maybe, well, Lisa, we'll start with you. We can finish your thought.
Yeah, because it actually dovetails off of what you're saying, is that we're delighted to see the increased investment European countries are making in their innovation ecosystem, because largely they're working on hardware projects. They have fantastic engineers in different countries, and Catalyst program in London and things like that. But we can partner with all of my company Xplore can partner with the hardware company. We can partner with them on services that we provide to them. So we're welcoming the collaboration with European countries that want to fly a satellite, might not know as well how to work on remote sensing instruments, and might not know the data game and how to work with data. So, space is global, and no matter where we turn, there's always another global partner that can elevate the industry. So I think it's great to be here today to have that global exposure and welcome people to get to know us. Thank you.
Final thought.
Quick final thought. I'd call myself a cynical optimist. So I think I have a pragmatic view on human behavior, but I'm at the end of the day an optimist, and I think we will solve our problems. Otherwise, there's no point, right? You have to believe that you will. My call to action, I think, would be, we get very attracted to the shiny technological cycles of innovation. There are other ecosystem concurrent innovation in ethics, in politics, in procurement, in many different things that need to happen at the same time. And I think it's critical that in times of high volatility, which I think we see over the next 5 to 10 years, optionality is powerful and resilience is powerful. And I think Poland and the Business Hub here has done a fantastic job of talking about societal resilience. It's not just technological. How do you have sustainability? How do you have access to critical resources? How do you look after your people? How do you build cultural resilience in this high tempo, high uncertainty time?
Okay, you terrify me. Give me your uplifting thought.
Why? Well, I think we are heading to the quite autonomous world with the different kind of applications and systems. And there will be this kind of like a space mesh, which is then combining the information. I see it as a whole, not just satellites or drones. It will be the whole ecosystem, which can work quite autonomously.
Okay. All right. Thank you. Johanna. Okay. Thank you so much for joining.